So we're here at the IDTechEx Show here in Berlin, and who are you?
Hi, I'm Kerry Adams. I'm Marketing Manager for DuPont Advanced Materials. So we're here to promote our various conductive and dielectric inks, which enable many different applications in the printed electronics industry.
So what are we looking at here?
So this is a brand new product. This is PE 410 inkjet silver. What we have here is a demonstrator enabled with this silver material. It's fully inkjet printed. It contains an NFC activation chip, and it also contains a capacitive touch switch. And actually, this is just to demonstrate the technology, and what you have here on the back is the circuitry with the embedded LEDs and you can either activate it with a smartphone or you can just do it with a capacitive touch switch. But the beauty here is it's fully inkjet printed.
Fully inkjet printed, but then you add the LEDs,
and that's
snap
mounted
them on?
afterwards. Yeah, they're mounted on afterwards.
So what's the advantage of having fully inkjet printed stuff?
Well, the thing is with inkjet printing, it means it gives you digital prototyping ability, so you can very quickly come up with a design, stick it in your computer, send it to your inkjet printer and print a fully functional electrical circuit or component within a few minutes. And then with that design you can scale up to bigger scale inkjet machines and even go into sort of pilot scale production, that sort of thing.
So when it's not fully inkjet printed, that means it's more complicated, it's more expensive?
It's just a little less flexible on the design. So if you want to do something via a more analog method of printing, you may have to go away and create either the printing plate or the screen, and then you have to get that made, and then you have to do the run. And any alterations then you have to change that plate or change that screen, whereas this you're just changing something on a computer. So this one just has the functionality there with the LEDs lighting up.
Where's the battery?
So that's in the base here. Yeah,
okay.
that's contained in the base.
And where's the touch?
So so it'll have to go off again before you reactivate it.
Okay.
Yeah.
Cool. And what are you looking at here?
So this is another range of inks that have recently been introduced by DuPont, and they are washable and stretchable inks, and they are used for things like you see here, which is turned inside out. It's a sports shirt with a series of sensors on it. And so what happens is that you print onto, let's say, a polyurethane substrate, and then you laminate that onto the actual shirt itself. And then those sensors can pick up your heart rate, they can pick up your temperature, they can pick up oxygen content, depending on what you're trying to measure.
That's awesome.
Yeah.
So how soon are we all going to have shirts on like this all the time?
Yeah, I think we'll be having them probably towards the end of this year.
That's very soon.
Yeah. People are in advanced prototyping stages, so I think sort of end of 2016, 2017, you'll see these sort of sports shirts around.
And these are some of the other. So this is. This is one for the shower, right? Right.
So this is called InMold Electronics. Okay, so this is not a working demo, but it's a very nice illustration that you can get a 3D shape from printing on a 2D surface. So
is it already mass production?
No. Again, this type of thing, the InMold circuits, again, are in advanced prototyping stage with a lot of companies, important companies in automotive and in white goods. And it's a very new technology, and what it does, it just removes the whole circuit board that would be here normally, and you've got here a very simple printed circuit, right?
That lowers the weight.
Lowers the weight,
of the
makes
car.
it easier to make, lowers the cost, increases the functionality, increases the
reliability also.
Yeah, and also just the sheer the functionality and the beauty of it compared to what it would be like. But also, you've totally removed a series of circuit boards here with circuitry on. Nice.
And this one?
It's the same. So this one is a demo that just shows what can be done. Again, this is an NFC-enabled device with various capacitive touch switches. But the point here is the form factor and the ease of use of the unit.
And this is what you usually. This is already being mass produced.
Yeah,
right?
these are our standard materials. So we've got silver, copper, dielectric, carbon. They're used in a variety of applications. Sorry, this one's particularly used in biomedical sensors, things like blood glucose sensing. And these are already in mass production, using billions of units.
Yeah. Billions.
Yeah.
And this is stretchable?
Yeah, this is the same technology as I showed you on the shirt. So this gives you a nice illustration of the material. You can stretch it and it still works fine, and you can wash it as well.
Nice. And what are we looking at over here?
Here we've got some new materials again. So what we've developed here is a Kapton branded ink. So Kapton is famous for film manufacture. It's very high reliable, high thermal stability in the films world. But now we've got an ink with the same qualities in its ingredients, and it's a Kapton branded ink. And so what it gives you is very high operating temperatures, where other silver inks would fail and would decompose. This one keeps working up to around 200, 225 degrees C operating temperature.
Wow, so you can use different materials for the substrate, right?
Yeah, well, in this case it's Kapton itself. So what it enables is, if you've got a heater that is operating up around 150, 200 degrees, you can fully print it. Okay, so it's a nice, thin, flexible heater in this case.
That's cool.
This is just an example of the circuit.
And this one is low temperature?
Yeah, this is like the opposite. So you're extending printed electronics in both directions. So you have here inks that are cured at as low as 60 degrees. So what it enables is substrates that are used traditionally for different applications, so like packaging and other types of applications. You can print directly onto polyolefins and PVC, things like that.
Can we grab this one right here?
Yep.
What is this? What is this about?
So again, this is a good example of what's possible. This is an NFC. It was in fact a sensor unit, and it's an NFC antenna and NFC chip integrated into a sensor circuit. And what we had here, we had a range of different materials. So you can have an inkjet one, you can have a screen printed one, you have low temperature curing materials, high temperature curing materials, but they all function pretty well. So you can vary the substrate, and in this case, in the showcase here, you can see one that's done on a stretchable substrate. So you can see it's bent round there.
That's cool.
So here you can stretch it, and it still works.
So all these awesome, amazing things are. Some of them are research, some of them are approaching mass production, some are in billions of devices.
Yeah.
And you're all over the range.
Yeah, we're on the range because we're constantly inventing new things. So a lot of the new things we're inventing, they're just coming up to being commercially available, and they'll be in the market in the next year or two. And some of the more traditional things we've been making, they've been on the market for up to 50 years in some cases.
And where do you invent those? Is it in all over the world?
Yeah, it's global research and manufacturing, yeah.
Cool.